If not, there's some up on the top. There's a few down here. Notes for before you take off. If you haven't already, come down and claimed your lab notebook in your final exam. They're down here in like some random kind of order, so feel free to grab away and see if you can get lucky. All right, welcome to the Organic 2 lab for the second semester. All of you are here. This is 256A, because this will meet for the first 7 or so weeks, so we'll talk about some more details on that as we go. By way of introduction, my name is Jeff Johnson, so I know a good share of you. For those of you I don't know, stop by my office and say, tell me hi sometime, introduce yourself. I'll be running the lab lectures here for this semester. So I have to admit right off the bat, I've never done this before, so good luck to you. All right. Hopefully we'll have things in order and be able to figure things out, and things will be pretty straightforward. But anyway, welcome to the second semester, and fasten your seatbelt. Okay. Some of the details. Everyone's got a syllabus. Let's just hit some highlights in there. We've done this sort of thing before, but we'll just take a look through. Ultimately, everybody should have a lab manual. So we've got the same one that we used in the first semester. If by chance you did not take Organic 1 last semester and you need a new one, come and find me. We've got a few extras and I can hook you up. So, but it is just a continuation of the same manual that you've got before. Also, you should have a new notebook. Okay, if you've got about 10 pages or less that you've used, maybe 20 pages or less that you used last semester, you can continue on in that one. Otherwise, just grab yourself another one from the bookstore. And we'll start over. And that's about it in terms of lab material. So it's nice in the pocketbook this semester. Okay. Hopefully everyone is set with their sections, and we've got those all arranged. If there's any confusion in that, please see me afterwards. So I'm sort of designated lab czar and trying to fit all of you into all of the lab sections. And so far so good, but it's really pretty close. So if you need to make any changes or anything, please let me know very soon. You'll note that the instructors are there. For the most part, there's only one section per time slot, so you don't have to worry too much about which lab you're in. The only exception to that is Thursday morning. There will be 2 lab sections going on. So take note of which section you're in and where that meets for sure. Okay, so Professors Fu and Gilmore will be able to sort that out for you if you have any questions. So it's kind of the usual suspects in terms of instructors. So I'll be teaching a section, and we have Stanford and Gilmore also teaching a section. Professor Wally Fu will be joining us for this spring semester. He's actually in the back if you want to give a wave, Wally. All right, Professor Fu will be teaching Tuesday afternoon and Thursday morning. So he has more organic experience than the rest of us combined. So here's the fount of all knowledge. Be sure you use it. Okay? He'll be more than happy to share his knowledge with you, I'm sure. So, all right, going forward, a couple of the major points. Let's see what's in here. Ultimately, you're here because you passed the first semester of lab, and if for some reason you haven't, let's figure that out sooner rather than later. A couple of the highlights that we need to put down. It's a half-semester course. The final exam for this course is during this lab period on the 29th of February, okay, on Monday the 29th. So write that down. I think I have that up here, perhaps. Okay, write that down, highlight that, circle it several times. Okay, I had that. Final exam, there you go. Monday the 29th at 4 p.m. All right, in here, we'll kind of split between rooms if we have to. But ultimately, if you have any problems with that, let me know now. Although if you have problems with that, you probably aren't sitting here in this room at this moment. So if your friends who aren't attending lab lecture have problems with that, let me know. Okay? So that's one to definitely circle on that. Ultimately, it's pretty much the end of the lab. So we've got about 2 months worth here. All right, if you continue on in the little syllabus here, second page, we've got a nice little schedule that you saw in the first semester. Okay, that'll give you the rundown on what we're doing. One thing I'll give you the heads up on, especially early, we bounce. It's not nice and simple. We don't go sequential. Okay, so the first experiment that we'll do is experiment 18, then we'll drop back to 17, then we skip up to 20. And so it's kind of a nightmare to sort of remember those things. That's why we give you this. Okay, so just like you saw last semester, that tells you where the quizzes are, it tells you when reports are due, and everything else. So be sure you take a look at that. Stay tuned. I'll try and remind you of those things here in lab lecture, but be sure you're looking at that, and your lab profs will explain those things as well. Okay. One thing to note, we do check-in this week, and I'll highlight this a couple of times. There is a pre-lab that's due this week in lab, and I'll give you some hints and tips on that as we go forward. But that's so your first assignment before your first lab is to get that pre-lab all set and ready to go. Okay. By this time, that's old hat. You've You've been doing that for a semester. But take care of that. All right. Otherwise, grading is there. I'm not going to go through all the details. You can take a look at that. We have the breakdown for all the reports are kind of built into here. Take a look on that on your own. If you have any questions, let me know. Same ideas with lab safety and lab rules. Okay, it's just an extension of the first semester. So if you survive that with all of your digits intact, you're doing the right thing. So keep it up. Okay. All right. It's okay. You can shuffle. That's fine. Or not. You're too serious. Let's see. Other things, if you do have issues in terms of ADA things, especially with that final exam, feel free to let me know, and we'll make arrangements for it. Okay. Ultimately, long story short, continuation of the first semester, and that seemed to go well enough, so let's just keep it up. Anybody have any questions with anything in terms of the basic schedule, the syllabus, things like that? I encourage you to read through it. Just be sure that there's no fine print in there that says that we're giving everybody in here a C and I'm not grading a thing this semester or something like that. It's not in there, but it could be. Okay, so take a look, read through that, and let me know if you have any questions. All right, with that, let's get down to business. What are we doing this week? Okay, what else do I have up here? All right, yeah, that was one other thing. I already mentioned that. Here we go, open lab hours. You're all familiar with the open lab concept, and if you have anything that needs to come back and you need to, take melting points or do final masses, you can write those down, but those are essentially the same as they've been in the last semester. Monday, Wednesday, Friday, 9:30 to 3:30. Okay, note that, of course, if we don't have class or something like that, we won't have open lab, but in general, that's your open lab times. Okay. One other note, as I mentioned, this is a half semester class. Okay, so as of essentially March 3rd, I think, or March 1st, whatever it is, that's the end of this section. Okay, many of you will go on your way and triumph in your completion of Organic 2 lab, and that's fine. Those of you who are interested in the second part of this lab, it is optional. It's an additional 1 credit independent projects. So just as a quick little advertisement here, what we do in that section is each of you, we do a little bit of background on how you do literature searching and things like that. And each of you come up with a 3-step synthesis that you can then pursue during the second part of the semester. Okay, so we teach you how to do the labs, we teach you how to do the research, look at the literature. You put that together, you order your chemicals, all of these sorts of things, and then following spring break, you actually get to go at it and do that independent project. Okay, it tends to be a lot of fun. It becomes much more kind of freewheeling than typical organic lab. If you're interested at all in like a future, and definitely if you want to be a professional chemist or a chemistry major with any focus in actually performing the sciences, it's not a bad thing to do if it fits into your schedule. So if you have any questions with that, come and let me know. If you're interested in it and are not already signed up, okay, let me know. We can do that all the way up until it starts. Okay, and if you have the opposite one where you want to run screaming away from organic lab, I'll sign those as well. I'm not as enthusiastic about that. Okay, but anyway, if you want to join, if you want to know more details, come and let me know. Okay. All right, questions on that? All right, and so now, like I said, okay, what's coming, what to expect. Okay, so what I'm going to try to do each week is give you a little bit of a tidbit, what we're going to do today, kind of what to expect this coming week, and so on. One thing I will note is you feverishly scratch things down. The PowerPoints I have here are available online on the Moodle site. Okay, I will try to get those up there, by at least Friday before lab lecture. We'll see how on the ball I am and how far ahead I am. Okay. But so these will be available, so don't feel like you have to scratch everything down. Okay, you can pull those up and use them as a resource even during the lab if you want. Okay. All right. So the game plan. All right, we're going to be doing experiment 18 in the lab. Okay, so that will be the plan for this week. 18 in the full experiment. Just a 1-week lab. All right, what we're going to do a pre-lab, so that's right now. I'll do the introduction, which I already have. Okay, experiment 18, I'll give you the rundown, what to expect, what we're going to do, hints and tips, and so on. If we have time, we'll touch on experiment 16. One thing to note, experiment 16 is simply a dry lab. It's just worksheets. Okay, it's all about NMR and things like that. Okay, between the end of lab today and lab lecture next week, I will give you some insight on how to do that. Okay, that will ultimately be due 2 weeks from now. There's no time in the actual lab that we'll work on that. Okay, so I'll remind you of that next week, and it'll probably make a little more sense when you've had a little bit more NMR experience. Okay, but at least keep that on your radar screen. All right, so next week, then we'll talk about experiment 17, part 1, and including that quiz for number 1. And then we'll talk about some NMR processing in the pre-lab. That's what we'll do next week. Okay? And what might be important 2 weeks from now is when the experiment 18 report is due and that experiment 16 worksheets are due. Okay, so just kind of keep those in mind as we move forward. All right, now experiment 18. All right, so experiment 18, identification of organic compounds. We did this once during the first semester, experiment 6. Then you got an unknown, you sort of figured out how it was, what it was, what functional groups it has. This is sort of like the blown up version. There's a lot more variables in here, a lot more possibilities. Okay, why do we bother doing something like this? Okay, what's the value of an exercise that, gee, I have this unknown white crystal in this vial to figure out what it is? Okay, the classical connection to something that actually makes sense is, okay, chemists or medicinal chemists or people that they work with will go out and collect different materials with the goal of bringing something back that will change humanity as we know. Right? Okay, that maybe smaller goals than that. But the idea is the next big pharmaceutical. Often these biological agents come from nature. Okay, so something that we dig up from the ground, something that we hack out of a tree, whatever it happens to be. Okay? Those compounds can often be tested without specifically isolating and knowing what they are. Okay? I mean, in its very crudest form, you can take this plant here, you can chop off these leaves, grind them up, and put them into a petri dish with some bacteria. Right? You see something like this, and okay, look, we have these places where we dotted it, and we killed all that bacteria around it. Okay? There might be something interesting there. Now you have to find out what it is. Okay? And so now if you want to think about how could these skills be useful, that's it. We have these compounds that, holy cow, we have some activity, this could be the next big thing. We have to find out what did we make. Okay? On one hand, it could be some exciting pharmaceutical. On the other hand, it could be sulfuric acid. Okay? One has the potential to be a pharmaceutical, the other just hurts. Okay? All right, so what do we have in there? Okay, so your task is to identify the unknown species. Luckily, we aren't going to send you, or maybe unluckily, we're not going to send you to some tropical forest to harvest things. You get a vial full of one single unknown that you have to identify. Okay? How are you going to do that? You're going to get your unknown, you're going to check it out as you did in the first semester. We're going to use chemical tests. We're somewhat familiar with that. We're going to use spectroscopy to identify that unknown. Once you've got a pretty good idea of what you think it is using those tests, using spectroscopy, then you go into the literature and you're going to match the spectra to see if you actually have what you think you have. Okay, so there's kind of the overarching game plan for this week. All right. Here are the possibilities, and again, definitely don't write all these down. These are all in your lab manual. Okay? All right. Your unknown will contain one of the following functional groups. Okay, so we have this whole series of functional groups that are possible. In addition to all of these, so all of these simply contain an oxygen or one or more oxygens. Or it can be something that contains one of these nitrogen-containing functional groups. Okay? In addition, so you're going to have one of these or one of these. Plus, you can have any of these function groups as well. Okay? So the goal then is to kind of decipher all of this and figure out what exactly do you have. And so we'll walk through, rather than just saying, okay, this is it, go. Of course, we're going to walk through and give you a plan on how to figure it out. All right. So the first things first, you'll notice all of these up here have oxygens. All of these over here have nitrogen, or nitrogen containing. So you're going to have one of these, and these can be secondary that you may or may not have. Okay, just to kind of clarify that. All right. Where do you start? You're going to have a flow chart. So if you look on page 18.8 in your manual, if you want to pull it out and follow along, it could be useful. Otherwise, it's there. Okay, you have a flow chart that looks like this. This is going to be the process. Start at the top, work your way down, and figure out where you go. What this is going to do is guide your functional group examination, and then ultimately let you know which of those primary functional groups, those two that I showed up on the top, which one do you have? All right. You'll note that right up there on the top is the determination of nitrogen presence. So the test for this is a sodium fusion test. This is a nasty, crazy test, and good news for you, we're actually not doing it this year. Okay? We had some complications in getting the material that apparently is an antiquated enough test that they don't even make some of these things anymore. All right. So we're not doing the sodium fusion test for nitrogen, but of course, we still have to figure out, does this compound have nitrogen or not? How we're going to do that this year instead is you're going to get some information, all right, about the elemental analysis of your compound. Okay. So what the elemental analysis of your compound is that's basically just a breakdown of what elements are in that compound, okay, and in what percentage by weight. Okay, so they have methods of doing this where you can figure out a certain amount of hydrogens, carbons, oxygens, nitrogens, chlorines, etc. that are in your molecule in your unknown. So you're going to get something like this. So you'll get an unknown tomorrow, then you will also get a little sheet that tells you what the elemental analysis is. Okay, so you'll see something like this, unknown, whatever you have, is essentially 60% carbon, 13% hydrogen, 26+% oxygen. Okay, so that will give you the elemental breakdown of what is in your compound. Okay, how do you handle this? What does this tell you? Ultimately, my suggestion on how you look at this is you simply divide each percentage that you get here by the weight of that atom. And then what that will tell you ultimately is the elemental ratio there. Note that the elemental analysis, as I mentioned, is purely by weight. It doesn't tell you the percentage by number of atoms or anything else. That's what you have to figure out. Okay? All right, so if we divide each one, just to show you how you do this, okay, if you take we have 60%, I'm going to round here, okay? So we have 60% of this compound is carbon. Okay? Carbon's molecular weight up there is 12. Okay? So we divide it by 12, it gives us 5. We've got 13.5 roughly of hydrogen, divide that by 1, the mass of hydrogen. It gives us this one. Then oxygen, same thing, we have 26% oxygen divided by 16, we get 1.6. So our elemental ratio here within this compound is 5 to 13.4 to 1.6, which doesn't mean much of anything to anybody. So you normalize this, right? Divide that all by 1.6, and we have a ratio of 3 to 8 to 1. Okay, so does that make sense? How we take the percentages, divide it by the mass of the atom, and then ultimately we get what the ratio is. Now I'll ask you, is the formula 3 carbons, 8 hydrogens, and 1 oxygen? It could be, right? It could be very simple and that's it. Or it could be, 9 and 24 and 3. It could be any factor of that, right? We don't know what the stoichiometry is. We just know what the ratio of those 3 elements is. Okay, so keep that in mind. That'll get you a long way towards what the formula of your unknown is. Okay, so ultimately that's the ratio, and as I said, it's just the ratio, not necessarily the formula. Okay. All right, any questions on how you figure this out using the elemental analysis? Like I said, I will have these are up on Moodle, so you can kind of pop them off if you didn't scratch everything out. All right, some other things that can help you out then. The molecular weight can usually be obtained from the mass spec. Okay, so remember we talked about mass spectrometry last semester. Okay, that molecular ion peak will tell you what the overall mass of your compound is. Put the two of them together and you can determine exactly what the formula is, okay, not just the ratio. Okay. One note, if the analysis does not equal 100, basically what we gave you is we gave you carbon, hydrogen, oxygen, and nitrogen. Okay. If there may be one of them missing, or there may be not 100%, that means it's an atom that's not those 4. Okay, so that is possible. So if they don't add up to 100%, you're missing something. Okay, and the hint of the day is that's going to be a halide of some sort. Okay, and then finally, the analysis will show nitrogen. So this example I gave you doesn't have nitrogen in it. Okay, it will show nitrogen. So when you go back to our original question of does my compound have nitrogen in it or not, look at that elemental analysis and see if there's nitrogen in it. And that's a heck of a lot easier than doing the sodium fusion test. Okay? All right. So long story short, that will tell you if you have nitrogen. So what I would suggest is for the first step tomorrow or Thursday when you do the lab, just simply look, do you have nitrogen, yes or no? And then move on. You can do the analysis as you have a little downtime or once you get a little bit more information together. Okay? All right. Okay, so moving forward. Okay, so that's essentially the elemental analysis of the replacement for that first step. Moving forward from there, okay, if nitrogen is present, you head down this row. Okay, oxygen, we'll go on that way. So let's just look at nitrogen present right now. Okay, if nitrogen is present, see page, 18-10. And then what that will tell you is your next test is to do a copper sulfate test. Ultimately, what happens here is a copper sulfate test, and again, I'm going to give you some highlights here. All the details are in your lab manuals, so you can go through and that. I'm going to basically highlight things to look for. All right, key with the copper sulfate test is amines coordinate with copper, and they make a color change. Okay, kind of the hard thing to look at, especially if you draw this, is it will make a color change, but a copper sulfate solution is sort of bluish, and then when you do this reaction, the copper sulfate, it often gives you like a bluish solution, okay? But it will change. Okay, usually if you have an amine, it's a distinct change from a blue to a different kind of blue. Okay, so you have to be watching pretty carefully when you do this. If you happen to be colorblind, talk to somebody next to you to help you out. Okay, but amines will coordinate that copper species and then give you a different color. And so here's how that works. Basically, you have this copper sulfate solution that's blue. You add the amine to it. You make a new complex. That's, like I said, it's just a different color. Okay, so it'll be blue, green. Sometimes it's going to precipitate on it. Okay, if you see that color change, that means you have an amine. And so note the amine, we haven't covered this in lab lecture. Okay, the amine is simply a nitrogen with 3 groups off of it. So they can be hydrogens on there, or they can be carbon chains. They are not a carbonate. That's really the important part. Okay, so they're either carbons or hydrogens. All right. So that's really about the only chemical characterization test we have for nitrogen. Okay, it's a really if you find yourself with a nitrogen there, it's a relatively short path there. You're going to have to really rely on spectroscopy and things like that. Okay? Beyond that copper sulfate test for nitrogen-containing compounds, you'll also want to do the solubility test. These are the same tests that we did back in experiment 6 last semester. Okay, so you know how to do those. One thing I will note, and I'll try to note this multiple times, do not use sulfuric acid for your solubility test if you have a nitrogen present. Okay, some of those, especially the amines, can react relatively violently with sulfuric acid. So there's a big thing. Be sure you put a little star in your notebook. Okay? Don't use the sulfuric acid test with amines or with nitrogen-containing compounds. All right, and so from there, the remainder of your identification is spectroscopic. Okay, so you're going to really have to rely on your NMR and your IR and your mass spec and things like that once you get to those those nitrogen-containing compounds. Right? All right, so this essentially is all the way down that right-hand side of that flow chart. Any questions on that so far? Yeah, Lindsay.
Do you want us to include that flow chart in the lab notebooks?
That's a good question. I don't think you need to.
Because I know previously that we were supposed to have flow charts in there.
Right. Yeah. Although this is a flow chart that's a whole lot of if-then maybes. So to be honest, I would suggest not. Okay? And if your lab profs this week yell at you for not having it, you can blame me. Okay? So yeah, I would say don't bother with that the whole lab. Yeah, to be honest, your flow chart this week is going to be pretty sparse. Okay? Just because there's a lot of maybe ifs, and if you have nitrogen, it doesn't make sense to do the whole rest of the flow chart. So if you have a nitrogen present, you're going to go right there and not have to deal with any of this. And so it would be kind of a waste to put all of that in there. Yeah.
So you're saying the elemental analysis, we can look at that to determine if we have nitrogens rather than doing a sodium fusion test?
Yes.
Sorry, we're just
Exactly.
not going to do a sodium.
We are not going to do the sodium fusion test. Okay? Big star, put that in the no sodium fusion test, which is really good. It's just like a witch's brew. And it looks cool when it works, but it takes a lot of effort to get there. All right? So yeah, so we will not be doing the sodium fusion test. All right, any other questions on that? All right, good. Okay, so that's it. If you have a nitrogen present, we go that direction. If the nitrogen is not present, that means you have one of those purely oxygen-containing functional groups. Okay? Note that the ones that have nitrogen, some of them do have oxygens as well. Okay? If we go this other direction, that means it does not have nitrogen, and there's only oxygen present in the functional groups. All right. And so if there's no nitrogen present, the first thing we do is the 2,4 dinitro blah 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 test, the Dmv test. Okay? And as we learned last time, that was the Dmv test told us about ketones. Okay? Here's what that test actually looks like if we draw out the compounds. You're not responsible for knowing all of the the allegory details on these. Okay? Here's my suggestion is know what the tests do and kind of the basics of what's going on. Okay, there won't be a quiz this week, okay, but this material may show up next week in your lab. You'll have to ask your lab profs for that. Okay? I always like to at least throw a reaction up so people know what's going on when we do these. So you've got a ketone or an aldehyde. Okay, so I will note that I think, well, last semester we did it with just with ketones. Okay, ketones or aldehydes are both possible and can both give positive tests with the DNP. So what happens is we've got the hydrazine will react with your ketone or your aldehyde, make this complex here. Ultimately, from last semester, what happens if you have a positive DNP test? Everybody together. You get that precipitate, right? It turns orange, and you get a precipitate. This doesn't show up really well on this. Ultimately, you have that clear orange solution as your DNP reagent. You end up with the orange, solid It looks like, you know, the Tang type solution there on the right. Okay? And so a positive test gives you this orange precipitate, and what that tells you is you have either a ketone or an aldehyde present. So that one's a repeat of something that we did last year. All right, remember the little hints and tips we gave you last time? Don't use acetone to clean a test tube before you do this, because of course that acetone falls nicely into the ketone category, and that will give you a positive test. Okay, so be sure you don't clean this with acetone beforehand. It's okay if there's a little watermark on your test tubes. Just go ahead and run the test. Okay, all right. So there we go. There's the reagent. That's what a positive test looks like. Okay, so from there we've seen that test before. If that is positive, okay, then you head down this branch of your flow chart. That means you have an aldehyde or a ketone present. At this point, as I mentioned, either of those functional groups will give you a positive result there for your DNP. And so the next step then is the chromic acid test. The chromic acid test will define whether you have a ketone or an aldehyde. Okay, so this is a new one. Okay, and what this looks like, ultimately we treat this with this is considered the Jones reagent. We'll learn about that in, I don't know, 4 or 6 weeks, something like that. And what that will do is with an aldehyde, it will oxidize that up to a carboxylic acid. Okay? The thing to note, it will oxidize it very quickly. It happens in about a minute or less. Okay? And again, don't sit there and look at your watch and count it. But don't let it sit there for 10 minutes before you look at it. Okay, keep an eye on it. You're going to get a pretty fast reaction there. Okay? What happens is this chromic acid reagent is orange-red. Okay? And then when you react it, you're going to get a blue-green. This chromium compound that comes out the other side is a blue-green mixture. Okay? So it's going to definitely change color. And here's an example. So you have to kind of squint and look to see if it's blue-green. Maybe that shows you a little bit of blue-green up there. Okay? But you see a pretty distinct color change. You go from this orange-red compound to something that's a blue-green solution. Okay? And again, the reason for the color change then is the formation of this chromium sulfate species that's in there. That's going to give you that color change. That'll tell you that oxidation is happening, which means you have an aldehyde, if that matters. Okay? One little heads up, or several heads up. It's a rapid test. Okay, it's going to happen very, very quickly. Okay. Ketones eventually will slowly get there and form some of this byproduct. Okay? And so what you want to do is be sure you kind of keep an eye on it. React it, let it sit there for a minute or two, and then look. Okay? If you give it 5 or 10 minutes, even a ketone will start giving you a false positive there. Okay? The other note, and this is really kind of a good take-home message for a lot of things, alcohols and phenols will also give positive results. They can also be oxidized in different ways. Okay? And so you need to be sure that that first one is right. Otherwise, you're going to get a false positive here, and you're going to be off on some wild goose chase. I guess with that, I'm also going to emphasize that throughout, you have this entire flowchart is just one of several different things that we're going to look at to identify. Okay? So be sure that you weigh all of your data together, okay, when you're making these the ultimate identification of your unknown. Okay? So don't just rely on one single thing and be focused in on it. Okay? Be sure you use all of your data together. All right, so there's the chromic acid test. Any questions on that one? Hopefully that'll be pretty straightforward. I mean, we like it when we get color changes like that, and we don't have to squint and decide if it's actually changing or not. That one's pretty obvious. All right, so back to the overall flow chart. If that one's positive, you end up with an aldehyde. If that's negative, there's no color change. Okay, then you have a ketone. Okay, so then at that point you're done. Okay, you've identified your unknown. Okay, if we take a step back, if you had a negative Dmv test, so there was no precipitate in that orange, no orange precipitate in that reaction earlier, you head over this side, so you know it's not an aldehyde or a ketone, so you can cross those off as possibilities. Okay, now down this side, you do the ferric chloride test. Okay, so this is another new characterization test for us. Okay, what that looks like, this is one's really simple in terms of the actual chemical reaction, is you simply take a phenol. Okay, so we haven't discussed this in lecture yet. A phenol is an alcohol that's directly connected to an aromatic ring. Okay, so you see the oxygen is directly connected. There's no other atoms in between. So it is a type of alcohol, but it's a very specific type of alcohol. Okay? So that phenol is reacted with a ferric chloride solution. Okay? Ultimately, we make this new iron complex, and there's a change in color. Okay? What's interesting here is we see a distinct change in color. This one's going to be kind of a yellowish solution. This is to start. The positive test in this case gives you this kind of a brownish orangish color. Okay. One thing of note is there's going to be a distinct color change. There's no promises on exactly what that color is. It turns out that this is actually very, very sensitive. And so a positive result here can be red, it can be green, it can be purple, it can be kind of bluish. It all depends on what exactly is there with the phenol, and then how many of these phenols we actually, these phenoxides we put on the ion. Okay, so there's a lot of different variation there that's possible. The key is it will change color. Okay, luckily it will not change color to yellow. Okay, so you're going to see something pretty dramatic there. Okay, so that's when it has a phenol. Keep in mind again that that phenol is a subset of alcohols, so only phenols will react with this. General alcohols will not. Okay, so it's very specific for the phenols. Okay, all right. With that, okay. If it's not a phenol, the next thing we do is we test for alcohols. Okay, the steric ammonium nitrate test, hopefully this one sounds familiar. Okay, this is the CAN test. Okay, you've seen this one before. Okay, that's actually what the compounds look like, and that's just a kind of a gobbledygook of what the reaction is. We can just get a complex and it changes color. Okay, the key is what we do is we change from the yellow reagent, okay, and that turns in the positive test will turn to an orange-red. All right, and again, this is one you've seen. We've got that yellowish. We turn this red color. That's a positive for the alcohol. Okay, and we can go from there. Okay. All right, not going to hit too much on ones that we've seen before. Okay, so if that is a positive test on this one, so this is one thing to note throughout. Sometimes positive tests will tell you exactly what's there. Sometimes they just sort of narrow it down a little bit. Okay, so we continue all the way through. If that one's positive, it's an alcohol. If it's not positive, okay, the next step then is to test for esters. Okay, so that's what the hydroxamate test for esters. What the ester functional group looks like, okay, we haven't covered this one in a lot of detail. It's the carbonyl directly attached to an oxygen, and then the R is another carbon chain. Okay, so both the R and the R prime in this case are both carbon chains. Okay, so that's the ester functionality. This is a two-step process. The first step is to form the hydroxamate. Okay, and so we take this alcoholamine here, and it'll form this compound. Then we treat it, so that itself doesn't change any color. It's kind of boring. It just sits there. You have to reflux it for a couple of minutes. Okay, to turn it into the hydroxamate. Then it will complex with the iron chloride, which then will give us a result that will tell us if we have the compound or the ester that we started with. Okay, so these react together to form the hydroxamic acid. Okay? And this is a bright purple color. So we'll see, when we add this ferric chloride, again, is a yellowish color, and it will give us a pretty significant purple color, and we get a positive solution. So you can see, here's an example of a test tube kind of light on its side, so you can see it's purple. Okay? Enough purple and it looks almost black, but you see a definite purple solution there when you run this test. Okay? And again, that gets you down to the ester then, with that functional group there. All right. Okay, yeah, so the little commentary on the reaction, this one is still colorless here. We don't get the color until we make that ferric chloride. We add that and then make the iron complex. Okay. Kind of a nice rule of thumb is, for the most part, organic compounds themselves tend to be colorless. They're really big in conjugating, you start getting some color. But you have to add in a little metal most of the time to get the colored results. Okay? All right, any questions on that one? Okay, we're almost done. Okay? Those of you who get this far, you're really going to have to keep it up, because you got to go all the way down to the bottom. A few of you unlucky people will get to do every one of these tests. Okay? All right. I promise we don't decide which unknown you pick just because we like you or not. Okay? All right. Down here at the bottom, if that one's positive, you have an ester. If it's negative, it's not an ester. The only things you're left with at this stage is either an ether or a carboxylic acid. Okay, so I don't know if you think back, how many of you had ethers in the last, back in experiment 6, or just alkanes? How you went through every single one and it was just negative, 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 negative? Okay, we have the same thing as possible here. Okay, so the last thing is the solubility test. When you get all the way down here, you want to know, is it soluble in the sodium hydroxide or not? Okay, an ether, okay, is a relatively non-polar, 2 carbons on the oxygen, that won't dissolve in sodium hydroxide. Okay? If it is soluble in sodium hydroxide, that means you're deprotonating it and making the carboxylate, and that is the positive test, and that means you have a carboxylic acid. Okay? And so with that, you've now made it all the way down and you figure out which functional group you have. All right. So that basically covers the primary functional group. Now you have to decide, do you have any secondary functional groups present? Okay. Some of these, you've all seen these before. Okay, the solubility test, like I just mentioned that you do. Okay, this, the standard rundown is there in experiment 6. You can look at that same table, it'll help you out. Okay, so we do those. Again, note that only in the absence of nitrogen do you do that sulfuric acid test. I don't have any details here on the alkene test. We can do these two tests to tell for the presence of an alkene. Okay, the potassium permanganate and the bromine test. The one thing that I would really emphasize is once you have this many functional groups present, it's possible that some react in different ways. Okay? So potassium permanganate, for example, can also oxidize alcohols. Okay? And so it's really key that you test both of these and they both agree. Okay? So if they both are positive, then you have an alkene. If one is positive and one is not, then you don't. Okay? So that's one to kind of put a little asterisk by that in your notebook, that these two come as a pair. Okay? You can get one false positive, okay? But they both must be positive for you really to think that you have an alkene. Because it is possible that, yeah, they'll do some other side reactions with others, but I don't think there are any that both of them will give you positive when you don't have an alkene. Okay? So do those together. And then also to test for halides. Okay, the good old Baustein flame test. So everybody should do this one as well. Okay, so go ahead and put a little compound in there and put it on the burner. And if you see that bright green flame, you know you've got a halide. Okay. All right, and so with that now, you should have a pretty good idea of the secondary test, and you've got your primary functional group, and that's all wrapped up. You should have a pretty good idea of what functional groups you have present.
Yeah, can we only have one secondary functional group?
I think so. I'm just trying to think of the whole list of unknowns there. I would say I think so, but if you think there's more than one there, it could be possible, or you could have a problem. So keep it in mind as a possibility, but I think it's just limited to one. Okay? And keep in mind that there is no test, for example, for an aromatic ring. You can't do a test like this with the alkenes or something. That's one that you just have to figure out. Okay? All right. Any other questions with the functional group tests? All right. A lot of information there, and again, for some of you, you'll just go down to nitrogen in the last 20 minutes. It's just been a waste. Okay? You should be familiar with all those tests, though. I promise you they'll come up again on quizzes and your final. So at least be familiar with all the tests. All right. The other pieces of information we're going to get. So that's just functional group. That's great. It'll tell you what's there. But of course, it won't give you any detail as to what the structure of your molecule is or what the identity is. Okay? We will also be doing a Gcms. Okay, so this is very, very similar to what we did with GC last semester, but it also teams it with mass spectrometry. Okay, so the sample prep is essentially the same. You'll put one drop of an unknown into one of these cute little vials, okay, or essentially 1 drop or 5 milligrams. Okay, you fill it up the rest of the way with the methylene chloride, and then you end up with a couple of pieces of data. Okay, the data that comes out, one, you're going to get the GC. Okay, so this is just an example of a GC. You'll note here that there's one super major product present. Nothing else is there. Okay, so this GC is exactly the same as what you saw before in last semester. One thing I'll note is you really can't get a lot of information in terms of identity from the GC alone. Okay, what this basically tells you is there's one species present, and that's it. Okay, and lucky for all of you is all of your compounds should be pure. Okay, they're unknown, but they're pure. Okay, if you see 2 peaks like this, one over here and one over here, let your prof know. Okay, there's a problem. Okay, so that tells you that. Again, there's no literature values or anything else for the GC. Okay? All right, the second piece of information you get from the GCMS is the MS side of it, and that's going to be a mass spectrum that looks something like this. Okay? So look back in your notes from chapter 12 of last semester. Okay, that peak that's farthest down to the right will most likely be your molecular ion peak, so that's going to tell you what the mass of your compound is. Okay, you'll also be able to get some fragments out of there. Okay, so you can use that data to get some information as to what the structure of your compound looks like. Okay, all right. The new compound. Any questions on the NMR? Or sorry, the GCMS before I go forward? All right. The new prep that we're going to do this week is NMR sample, or like an NMR. Okay, so we will actually make the sample to run the NMR. We'll do processing and some interpretation next week. Okay. The sample prep, similar amounts to the GC and GCMS. Okay, it's about 5 to 10 milligrams of a solid or 1 drop of an unknown. Okay, the tubes are a little bit different. They're kind of like, pencil shaped. Okay, so they're going to be relatively thin. Okay, about 7 inches tall. Okay, they're going to look like that. There's some little nuances that I'm going to emphasize now. Your profs will emphasize this in the lab as well. Okay. Typically, you put your solid unknown in there, or you go ahead and just dip your pipette in there and get a little liquid in the bottom. The solvent we use for this is CdCl3. Okay, it's deuterated chloroform. Okay, so what's with the D? Okay, it's an isotope of hydrogen. Okay, so we're going to look at that's deuterium instead of hydrogen. And the reason is, we haven't really covered enough in lecture to go through this in detail, is we're going to take the NMR of this, and if you use regular chloroform, CHCl3, and then you take the NMR, what are you going to see in that sample? The solvent. You're only going to see chloroform. You won't see your compound at all. So what we do is, as the solvent, we use deuterium. Because it's a different isotope of hydrogen, we can't see it in proton NMR. Okay? And so the solvent is essentially invisible to the NMR, so all we see is our sample. Okay? So it's really, really important to use a deuterated solvent when you do an NMR. All right, some little hints and tips. Don't contaminate that, the bottle of deuterated chloroform. If you take a pipette that you've used somewhere else and you put it into that bottle, it has a little ether in it. That little bit of ether goes into the sample, and now every single sample that's done after it all has your little bit of ether in it. Okay? I know tis the season to be giving, but you don't want to give like that. Okay? So to be very careful. We will have a single pipette there that you should pull it out of there, put it into your NMR tube. Be sure you don't contaminate it. If you think you do contaminate it, just get rid of it. We'll get a new pipette. Okay? We want to keep those bottles nice and clean. Okay? You'll see here in the next coming weeks they won't be nice and clean. You'll get a little bit of stuff in them and things like that, but we want to keep that to a minimum. Okay? So be really careful with that. Okay? Ultimately, again, you'll get more detail on this. You fill it to about 5 centimeters. Okay? My little tip of the day for you is that's about 3/4 of a pipette full. So when you pull the solvent up in the pipette, if you cram that bulb all the way down and pull it up, if that's a full pipette worth of solvent, you want about 3/4 of that is what will fill an NMR tube to the appropriate amount. Okay, about 5 centimeters, 2 inches is the right amount. Okay, we have a guide in the lab, and so you can look at it. One little hint I will give you is it's not exact. If you have a little bit less or a little bit more, it's just fine. Just don't fill the tube all the way up. Okay, we'll yell at you for that. All right, any questions with the NMR? All right, and so what you'll do is you'll simply submit that sample this week, and then we'll get the data back. Well, actually, we'll teach you how to process that and get your own data back next week in lab. Okay? All right. Okay, so you get all this data. So let's see, what else am I thinking? There's also an IR. You know how to take an IR. That's old hat. Okay, so you add IR to this. Now, at this point, by the time you're done with lab this week, you'll have taken an IR, you'll have submitted a mass spec and an NMR, and you'll have done all of those chemical tests, or at least as many as you're kind of directed to do. Solubility, the secondary test, and the flow chart. It's kind of a busy week. Okay? So you have all that information, and now in the course of the next 2 weeks, you have to use all that data to figure out what your compound is. Okay? Highlighting a couple of things on what to do with the report. Okay? To make you happy, this isn't the full report. Okay? This is one where it's kind of one of these workshop jobbies. This is what it's going to look like. Okay? Ultimately, this is pretty straightforward. Once you identify the unknown, you can draw it in there and you can name it down here. Okay? Be sure you fill in those details. It helps us out. A couple of quick little changes. This says results from sodium fusion. Okay, please change that to elemental analysis. Okay, so mention your elemental analysis there. That's a great place to say, okay, what did I get in terms of the ratio of my compound or something like that. Okay, so that's a great thing to put right in there. One other thing I'll highlight is each of these sections in the report worksheet has this nice little thing that says conclusion. Okay, so tell us, what did you figure out from the results in that section? Okay, in this case, that would probably be the ratio of your unknown, so it kind of goes together. Okay, and so what I really want to stress that you do in this report is for each section, basically tell us what you figure out from that section. Take all of those conclusions and then ultimately identify the molecule. Okay? We really want to push you from the interpret your data and come to a conclusion rather than finding some literature that match, and then play the matching game. Okay? We all know that you can match. All right. Okay, the rest of that, you'll see summary of solubility tests, chemical tests. Just highlight these in there briefly. No big deal to go into a lot of detail. And then again, what's the conclusion? At the end of the day, it's a small, non-polar functional group, etc. Here, consistent with a ketone, whatever it happens to be. So just whatever you get for each of these in here, and be sure to highlight that conclusion. All right. Okay, as said. Okay, the second page. Couple other things, physical properties. Yeah, you can put it in there. List of possible compounds. You shouldn't have many, right? You should interpret it and be able to predict that first. Okay. Some of the highlights in here. You can't read it from there. Okay. You want to include IR and NMR data tables. Okay. So just like we talked about that last semester with the IR, we will tell you that next week with your NMR. Be sure you include your spectra and the data table. Okay. Include the interpretation of the mass spec. I would say do that right on the mass spec that you get. Kind of highlight a little bit. This fragment means this. This is the molecular ion peak. Hit the highlights there. Okay. All right. Be sure, I'll remind you of this later. Be sure to attach the experimental spectra once you have those, and then attach the literature spectrum. Once you put all of this information together, the NMR, the IR, all of your other data, you should have a compound or two. Couple of things that you think your compound is. Right? Take that, then you go and look up the literature and see if they match. Okay? Heads up for you is that IR will match. Here, you're familiar with the IR. It matches very, very well. NMR matches typically quite well as well. They're going to be very, very close. Things like mass spec, I'm trying to think what else you might get. Okay, those are a little more wishy-washy. Okay, so IR and NMR will be the two that should pretty much overlay perfectly. Okay, so be sure you attach those and don't forget to cite sources. All right, and on the conclusion of this, what I really like to emphasize is again, focus on the interpretation of everything, and then match it at the end. This is why I think I have 2-butanol, and then I pulled up the spectra from 2-butanol, and lo and behold, they matched. Okay, so that's kind of the approach that you want to take in writing up that conclusion. All right, any questions on that? All right, a couple of quick little last notes here for you. All right, suggested data tables. I'm not going to go through all these. These are up, again, a reminder, these are up on Moodle. Check with your profs for specifics on these. Okay, that's generally what they're going to look like. Okay, again, they're going to be up on the Moodle site if you need them. All right, finding the literature spectrum for each compound. Okay, if you look on page 1616, that will tell you where you can find them. These are 3 different sites that are useful. Okay, just Google SDBS. I will tell you that's my go-to for about 98% of spectrum. So if I just Google SDBS, pull that up, look at the NMR. One thing I will tell you to be careful of is make sure that the IR is thin film or neat. You've run into that one already and seen the different varieties. Okay, NMR spectrum, be sure that it's the same solvent. Okay, one thing I will tell you is IR spectra taken in chloroform should be nearly overlaid and identical. You can take them in a different deuterated solvent, and then all bets are off. Okay, things move around. Okay, so be sure that you keep it the same solvent. And I will say mass specs are generally not terribly available. Some are, some aren't. And those, depending on the instrument and the type of system used, don't always match in terms of intensity. So they can help as a suggestion, but definitely not like an overlaid match. Okay? All right. And of course, be sure you cite the literature. Okay? All right, any questions with anything? That's a lot of information, but there's a lot of stuff we're covering this week. So, one last little nugget for you. Okay, one last little nugget for pre-lab to help you out. There are a million different tests and all the chemicals and stuff that go with it. Up on the Moodle site, this is incentive for you to go find it. I have an Excel sheet that has the beginnings of a data table. Okay, the physical information of all the compounds in there. Go grab that off the Moodle site and use it. Okay, it'll help you out in terms of finding them all or whatever else. Okay, if you have any questions, come down, let me know.